I want to tell you about a morning I still think about. It was about 3 years ago. I'd just woken up from a decent night of sleep, in a comfortable home, nothing catastrophic waiting for me. By every external measure, things were fine. And yet I sat at the edge of my bed and felt flat. Not sad exactly, just hollow. Like someone had turned the volume down on my whole life. I remember sitting there thinking, what is wrong with me? And that question became the thing I couldn't put down. Because I'd always just assumed happiness was something that happened to you. You get the right circumstances, the right relationships, enough luck, and happiness follows. And when it doesn't follow, you assume something's broken in you. I believed that for a long time. I could stay on what I felt that morning, the frustration, the confusion. But what actually matters is what I found when I started digging into the real science of what was happening inside my brain. Because the answer wasn't what I expected. At all. Here's the thing nobody tells you about happiness. Most people think it's a feeling you either have or you don't. A state that arrives when conditions line up. But neuroscience has a completely different picture of what's actually going on. Your mood, your thoughts, your emotional patterns, they're not fixed traits. They're learned responses, shaped by how your brain got wired over time. And thanks to neuroplasticity, the brain's actual ability to change and adapt, you can retrain your mind toward more positivity, more balance, more resilience. Read that again? Your brain isn't a fixed object. It's more like a landscape that shifts based on where you keep walking. The paths you travel most become the easiest ones to find. And the science behind this is way more specific and actionable than most people ever hear. So let me walk you through 3 habits, 3 real, physically real habits that change the actual architecture of your brain. Not metaphorically, literally. The first habit, gratitude, but not the way you think. I want to be careful here, because the word gratitude has been so overused it barely means anything anymore. Journal your gratitude. Write 3 things. Be grateful. You've heard all of it. Almost nobody understands why the brain actually responds to it. So, let me explain what's happening underneath the words. Neuroplasticity works through a well-understood mechanism. Neurons that fire together, wire together, that's Hebbian plat. When you repeatedly activate a neural circuit, the connections in that circuit get stronger. Simple enough, right? Here's where gratitude gets interesting. When you practice gratitude consistently, you're repeatedly activating the circuit connecting the medial prefrontal cortex, the anterior cingulate, the ventral striatum, and the brainstem nuclei that produce serotonin and dopamine. These aren't abstract regions. These are the parts of your brain responsible for emotional regulation, reward, motivation, the basic sense that life is worth engaging with. Dopamine acts as a learning signal. It tells your brain, that was valuable, do it again. Every time gratitude triggers dopamine, it strengthens the neural connections that made that experience possible, which creates a feedback loop. Practicing gratitude makes it neurologically easier to notice things worth being grateful for. And that changes everything. It's the opposite of what happens with chronic stress, where repeated activation of threat circuits makes the brain progressively more reactive to perceived danger. Gratitude gradually tilts the balance the other way, building a brain that defaults more toward reward than threat. Most people think they're doing gratitude wrong when they don't feel an instant mood shift. But research from Indiana University found that people who practiced gratitude journaling for several weeks showed altered neural activity in the medial prefrontal cortex that persisted months later. Months after the practice had stopped. That's not a mood trick. That's a structural change. And here's the detail Most people skip specificity matters more than volume. It's not about listing 20 things. It's about sitting with one thing long enough that your brain actually processes its value. Savoring is what strengthens those neural pathways. Even a few seconds of genuinely dwelling on something good is doing real neurological work. I had to sit with this for a while before I got the difference. There's a version of gratitude that's mechanical, a checkbox, and there's a version that's neurologically active. One changes your morning, the other gradually changes your brain. The second habit, movement, and the molecule nobody talks about. Here's what drives me a little crazy. When people talk about exercise making you happier, they usually stop at endorphins or feeling accomplished, which, sure, true, but it's almost embarrassingly incomplete. There's a molecule called brain-derived neurotrophic factor, BDNF, and understanding what it does completely changed how I think about movement. Aerobic exercise elevates BDNF levels in key brain regions like the hippocampus, triggering neurogenesis and synaptogenesis, new connections, new cells, in an adult human brain. Neurogenesis. For decades, scientists believed the adult brain couldn't grow new cells. Whatever you were born with was what you had. Then, the research on BDNF started arriving, and that assumption just crumbled. Movement, specifically aerobic movement, triggers production of the very protein that tells your brain to build new connections, grow new cells, repair circuits worn down by stress. Beyond the neurotransmitter effects, more serotonin, more norepinephrine, less cortisol, the BDNF signal is doing something deeper. It's literally building new infrastructure in the emotional regions of your brain. A 2023 review in Frontiers in Physiology analyzed over 100 manuscripts across 2 decades and found that both antidepressants and acute exercise, particularly high-intensity activity, elevate BDNF in healthy and clinical populations alike. Here's what I think we get wrong. We've convinced ourselves exercise is a body project, something you do to look a certain way, manage weight, have more energy. And because we frame it that way, skipping a day feels like an aesthetic failure rather than a brain maintenance failure. But your prefrontal cortex, the part of you that regulates mood, makes decisions, keeps anxiety from spiraling, it depends on the same BDNF signal your legs help generate. And the threshold is lower than most people think. You're not training for a marathon. You're triggering a molecule. 30 minutes of elevated heart rate is enough to produce measurable BDNF changes. Walking counts. Cycling counts. Your brain doesn't care what the workout looks like. It just needs to know you moved. The third habit, genuine social contact, the one we're getting increasingly wrong. This one I find the most quietly urgent. When we connect with others, share a laugh, have a real conversation, the brain releases serotonin, oxytocin, and dopamine. It reinforces the reward system. You feel better because you're literally running the chemistry that's supposed to run when humans connect. That's not fluffy. That's biology. But here's what changes when you look at the other side. Loneliness activates brain regions linked to pain and threat, the amygdala, the anterior cingulate cortex. Chronic loneliness disrupts dopamine and oxytocin pathways, gutting motivation and social reward. And prolonged isolation actually reshapes neuroplasticity, making it harder to reconnect over time. That last part should stop you cold. It's not just that loneliness feels bad. Sustained loneliness literally rewires your brain to make connection feel more threatening and less rewarding. The longer you're isolated, the harder reconnection becomes, not because of who you are, but because of what's happening chemically. The brain treats social rejection like physical injury. And what underpins the positive version, what actually happens when we connect, is oxytocin. Social interaction, and especially social touch, regulate oxytocin signaling. Lonely individuals often have an oxytocin imbalance that directly affects their health. That link between loneliness and oxytocin is neurobiologically established. Now here's the piece I think almost every conversation about this misses. We've substituted quantity for quality so completely we don't even notice anymore. Hundreds of online interactions, thousands of followers, constant digital contact, and still the oxytocin signal isn't activating the way it was designed to. Because what actually moves the needle is emotional support, not passive consumption of other people's content, not shallow engagement. The brain is running a chemistry check on your interactions, and it's looking for something specific, genuine mutual exchange, felt safety, the sense of being known. That's what triggers the oxytocin cascade. That's what actually does something. Chronic loneliness makes you twice as likely to develop depression compared to people who feel socially connected. Twice. I'm honestly still not sure how to sit with that number, because we're living in an era with more communication tools than any point in human history, and people are reporting record levels of loneliness. Something important is hiding in that gap. What changes when you see this? I want to bring this back to that morning. The hollowness I felt wasn't a character flaw. It wasn't a sign I was broken or ungrateful or weak. Looking back now, it was a brain running on the wrong input. Not enough depth in social exchanges. Movement had drifted away, and my attention was trained almost entirely on what was missing, what could go wrong, what needed fixing, which is exactly what an untrained brain does, because we evolved with one primary goal: survival. To keep you safe, your brain prioritizes threat detection over pleasure. That's the negativity bias. It's not a personality problem. It's neuroscience. The brain you wake up with tomorrow isn't the brain you're stuck with. Studies consistently show that regular practice changes brain structure and function. Gray matter density increases in the prefrontal cortex, the region tied to self-awareness, emotional regulation, decision-making. Activity in the amygdala decreases, reducing stress and anxiety over time. 3 habits, not 10, not a full life overhaul. Gratitude practiced specifically and slowly. Movement that elevates your heart rate and triggers BDNF. And real social contact, the kind that asks something of you and gives something back. These aren't feel-good suggestions. They're instructions for a physical process already built into you. Your brain is waiting for the signal. The only question is whether you're going to give it one.